This is a presentation on the standards for educators that are around computer science and computational thinking. In this emerging subject area, most everything is new and new to the people who are trying to use it. So we would like to offer a walk through some of the standards, where they've come from and where they are right now. This is from the Maryland Center for Computing Education. My name is Diana Grady-Cuniff, and I'm the director of the center. A while ago, in the late 1980s, the ISTE Standards for technology came out. If you think about the late 1980s for perspective, this is about the time when Microsoft stock was around 37 cents a share. So computer science wasn't really on most people's radar, but technology was getting to be. And so these educator standards, when they came out, were really focused on being a good digital citizen, using technology safely and effectively, and how to help students use technology as a tool for learning. So these were the first steps in the path towards computer science and computational thinking within education. These standards have been updated many times, and they're still very worthwhile, and they're the foundation to be able to use technology in order to be able to create with technology. Computer science sits within technology, and within computer science is computational thinking. So computational thinking is the part of computer science that has to do with figuring out problem solving, how to use a computer to effectively come up with solutions to problems, and directing the computer to do that. Cybersecurity and cyber safety are an area that overlap significantly with computer science. They're also part of the technology picture. And tech integration is more off to the side. It has to do with using the technology that other people have created effectively. Since computer science is kind of the new kid on the block in technology, a little background on the standards. The standards for K12 are divided up between the educational technology standards, the computer science K12 standards, and the framework that was developed for CS for All. Each of these things have gone through multiple evolutions to get to where they are in this area that changes so much and so often. The educator standards came later, and all of the ones that are out now have been a collaboration between ISTE and the CSTA. Ones for EdTech, ones for computational thinking, and the ones specifically for computer science teachers, which are the newest. The best place to start is to be familiar with the K12 computer science framework, very much the way that the NGSS decided to define science by being the concepts and practices that make up the art of science. These are the concepts and practices that make up the art of computer science. And you can see from this diagram of practices that these are the standard practices that are good education and solid things that people should know. Fostering an inclusive culture, collaborating, defining problems, developing tools, creating artifacts, testing and refining, and communicating. Those are the key practices of computer science. And being familiar with those makes it easier to understand the concepts themselves. So the 5 core concepts to computer science have to do with understanding the physical devices, the actual machines, the way they communicate, networks and the internet, the data that they store and what can be done with it. This is an area where artificial intelligence fits in quite nicely. The algorithms and programming, the actual step-by-step clear instructions that a person gives to a computer in order to solve problems. And finally, a part that's been greatly ignored, but is so important, and I'm sure we all have stories we can tell about the impacts of computing and how important it is to think about what the results are of the technology that we create before they wreak havoc. So the computational thinking competencies came out first a few years ago. And so computational thinking is more about integrating the concepts of computing into other subject areas. And so within these 5 areas, I'd like to dig a little bit deeper to see how that looks. So the teacher as a learner, because this is such a new field and because so few people who are educators have any background in computer science themselves, this is an ongoing place to be learning. but also because this is one of the most rapidly changing fields possible. So setting learning goals, being able to connect with opportunities, leveraging the resources and experts that are around, developing resilience and perseverance, because this is very much a problem-solving type of a discipline, and then recognizing how computing and society interact and how that looks from a teacher's perspective. The teacher as a leader in the computational thinking competencies. Pretty much everybody who's a computer science teacher at this point is a leader, because there are so few people and yet the demand is there, and there's so many opportunities to explain and to encourage others in this field. So as a leader, to create that positive identity for each student, you can do this. It's just a question of persistence. To be able to create activities that are culturally relevant in a field that's typically been very single-dimensional. To use approaches in teaching that are inclusive and to avoid the stereotype threat, which is very real and keeps a lot of people out of computing. To be able to work in the classroom culture for equitable student participation, which is part of that solution. The teacher as a collaborator is one aspect of computational thinking competencies. To be able to model and learn solutions and problems. To be able to support student collaboration. And to plan collaboratively with other educators, because most often people who are working in computer science or computational thinking are doing it kind of experimentally and maybe somewhat alone, and the collaboration has been a really important part of moving this forward. As a designer, the teacher would be looking to find ways to support problem solving and learning that connect to other content areas, to try to design authentic activities that use the design process, much like in engineering, where you're going through the process of actually creating something. Then to guide the students about the importance of diverse perspectives, and then to create learning environments that encourage varied viewpoints, student agency, creativity, engagement, joy, and fun. One of the great courses that has come out is The Beauty and Joy of Computing. And it seems like it's a subject area that many people are intimidated by, but it can be one of the most satisfying to teach, because the interaction, the engagement, students that discover a talent that they didn't know that they had, it's a lot of fun to teach once you feel comfortable with it. So as a facilitator, the teacher would be evaluating curriculum and other resources, trying to find meaningful projects that connect, and then being able to take any problem, break it down step by step in details using algorithms. And of course, like any subject area, effective assessments that inform instruction. The equity challenge in computing is really big, and you're going to see this reflected in every set of standards. That's because it's a challenge of both opportunity and perception, and really it's the perception that drives the opportunity. Because people in computing have been so kind of monocultural, there's great underrepresentation in terms of gender, race, ethnicity, disabilities, socioeconomic level. People in very urban areas or very rural areas often have no opportunity at all to get the exposure, whether it's an after-school club or camp, an opportunity in the summer, something at home. Only a very small group of people have typically been given those opportunities, and therefore only a very small group of people have felt like this is something they could do. And having polled over 1,000 students, you can see from the chart on the right that the male students are far more likely to be interested in taking a computer science course in the future than the female students, because of all of those different reasons. So teachers can make that difference. The computer science teacher, as opposed to the computational thinking integrator, would be someone who's actually teaching computer science as a course, maybe just as a significant unit. And so the 5 standards for CS teachers are outlined here: the knowledge and skills, the equity and inclusion, professional growth and identity, the instructional design, and the classroom practice. You'll notice there's a lot of overlap between the computational thinking and the computer science teacher standards. Looking into each of these areas a little more, we've already talked about how the K12 Framework has defined the concepts and practices that are computer science, how equity is a serious problem in the computing field, and how ongoing growth and being a learner is an important part of being a computer science teacher. The other areas that have to do with the classroom practice are the same kind of good practice that you'd be using in any other area, just understanding how those things work in computer science. To use inquiry, cultivate a positive climate, promote student self-efficacy, support collaboration and communication, and then to analyze the tools, align things to standards, use effective assessment. All of those things would be part of the educator standards for computer science that they should know. If you look at a sequence of 4 courses that might make up a program to prepare a computer science teacher, you would hope that all of these areas in the computer science teacher standards would be introduced, reinforced, and then mastered across the courses that are in the sequence. And so looking into the CS Educator Standards, you can see that the practices and the content that make up computer science are under the CS knowledge and skills, the understanding of the problems of equity and inclusion, the need for continued professional growth and identity, the ability to design effective curriculum instruction, and the practice in the classroom are all outlined here and make up the CS teacher standards.